How to calibrate an ammeter using a potentiometer. Our two major huge steps are, first of all, to find the PD per unit length of this wire, that is calibrating it. We are going to connect S to position 1 and we balance it against the AB. Then afterwards we connect S to position 2 and we balance this lower portion of the circuit against the wire AB, and then we are able to get the calibration curve of the ammeter. So we begin our experiment this way. Of course, first of all, we will establish our experiment and connect it like we have seen right there. After connecting our circuit diagram like that, we are going to put S to position 1 with K open. When we put S to position 1 with K open, we slide this jockey along AB. When we slide this jockey along AB, we will get an approximate balance point, and that approximate balance point is gotten when the galvanometer shows no deflection. So afterwards we will bypass this protective resistor by closing switch K, and when we close switch K, while this S is still on position 1, we will still tap our jockey along the slide wire AB up to a point where the galvanometer shows no deflection, and then the balance length is obtained and we're able to get our accurate balance point. And when we get our accurate balance point, when S is on position 1 and ES, this is a standard cell, it means that we are able to get the PD per unit length of that wire AB, because the potential difference across that balance length will be equal to the potential difference across our standard cell. So we'll go ahead and say that the PD across the balance length that we get is equal to the EMF of this cell, and that's how we're able to get our PD per unit length. And that is our first expression, that the ES, which is the PD across the standard cell, is equal to the PD per unit length K times LS. We have called that balance length LS. So from there we go ahead and connect S to position 2. When we connect S to position 2 with K open, it means that we are trying to balance the resistance of this standard resistor across the wire AB, this slide wire. So with S on position 2 while K is open, we'll go ahead and tap the jockey along the slide wire AB. Then we'll get an approximate balance length. Then after getting the approximate balance length, which is got when the galvanometer is not showing any deflection, we'll go ahead and close switch K so that we bypass the protective resistor. When we close switch K, we continue to tap this jockey along this wire AB, and then we will be able to get our accurate balance point. And when we get the accurate balance point, it means that the potential difference across this RS is equal to the potential difference across the balance point we will have gotten. So that's our expression, that the IA, which is current going through that resistor, times RS is equal to KL. When we substitute for this value of K, the PD per unit length, which is ES over LS, which we got in our first equation, we're able to come up with that expression when we make IA the subject of the formula. And so we're able to get the actual amount of current that is flowing through this resistor, RS. So when we get the amount of current that is flowing through this resistor RS, what we do here is, now we continue and carry out this experiment again. So it means that we will keep adjusting this rheostat, or this variable resistance, so that we get new values of current I. When we get new values of I here, we repeat the whole experiment and we keep getting different values of IA. So as you repeat the experiment, you adjust this rheostat to get new values of A, or new values of current, or new readings on the current. Then we carry out the experiment and we're able to get the amount of current that is actually going through the resistor, the standard resistance. Using this expression, we tabulate our results. By tabulating our results, I mean that we are repeating the experiment with different values of the ammeter reading, with different readings on the ammeter reading. When we do so, we are getting corresponding values of, we record the corresponding balance lengths, and when after recording the corresponding values of balance lengths, we are able to get the actual current that is going through the standard resistor using this expression right here. So after tabulating our results, we draw a graph. of IA against I. And the graph of IA against I gives us the calibration curve for the ammeter. And that's how we calibrate an ammeter using a potentiometer.